Here we have a selection of products from the vehicle measurement technology range. We have our 94-part measuring cable set with the various cable adapters here. These can be reordered individually. The measuring cable set contains 2 adjustable polarity testers, which can be changed from 0 to 5 kilo ohms. 2 two-color LEDs are also included. Check if injectors are positive or earth-controlled. Very flexible measuring tips that do not break right away are also included. In addition, a measuring tip set, TesTip Mini, can be purchased for more delicate work. Every workshop should have a multimeter. The Ampere pliers can be used to measure high currents up to 400 A. We also offer a wide range of test lamps, voltage testers. A frequent problem is that the battery is installed in the rear of the vehicle. I want to measure at the front though. All the individual cables are not long enough, even if I put all of them together. That is the reason why we provide customers with a cable drum, which is used for measuring cable extension. This enables me to extend my test cable to 6 meters. Using various vehicles, we will now show you how all of this works and what we can do with the individual products.
We need to quantify the voltage reduction in this specific instance, measure the voltage drop. We have our multimeter, our terminals, and our extension cable. First of all, we extend the cable. To the driver's seat at the front, where I then connect the multimeter. At the rear, we connect our terminals to the battery, positive and negative. Now we take our multimeter and set it to volts. We now see 12 volts on the display. We start the engine and check that it doesn't go below 10 volts. Our value was 10.5 volts. Another example is measuring the starting current. The battery is in the rear again, which is why we use our cable extension once again. We pull it out and take our multimeter with us. We connect the multimeter to positive and negative. Now we connect the other 2 ends to our measuring cables. We connect the measuring cables to our Ampere pliers. We now walk to the front and turn on our multimeter to volts. We connected our measuring cables to the positive and negative of the volt indicator. The millivolt number will then be our ampere number later. 1 millivolt approximately corresponds to 1 ampere. We now set it to 400 amperes because we want to measure the starting current. We press the 0 button and hold it in front of the negative cable. We thus zero the Ampere pliers. We place the clamp around it and walk to the front to start the engine. We have over 300 amperes of starting current, i.e., everything is okay.
This vehicle has a problem in that the window regulators no longer move up and down. This can have various causes. Either the motor is broken or the switch is faulty. To determine this, we use our test lamp voltage tester. This enables us to emit voltages and change polarity. This enables us to control the window regulators and check whether the motor or switch is faulty. To do this, we connect the test lamp to the positive and negative of the battery. Now we can take measurements in the vehicle, preserving meaning and length. We've connected the test lamp to the battery to find out the cause of the fault. To do this, we take a mounting wedge from Elparts bus and remove the switch. Then we remove the connector. And now we can control the individual functions after looking at the vehicle circuit diagram to see which pin it is. I take the connector here. According to the circuit diagram, terminal 4 is the rear window motor. I actuate it first. I go to terminal 4, apply voltage, and see that the window regulator moves down. I go to terminal 5 and see the window regulator move up again. That means the motor is okay at the rear. Now I go to the front window regulator, which also doesn't work. It also moves up and down. That means we have found our fault. The motors are okay. It is the switch unit that is faulty. Here we have a customer who complains that their engine is not running smoothly. We want to use our test Elparts voltage tester to measure inductively whether the same ignition voltage is applied to every cylinder. To do this, we start the engine. As we can hear, the customer is right. The engine is not running smoothly. We now test what the ignition voltage on the individual cylinders is like. To do this, we use our test lamp on the ignition cable and can determine inductively that 26 kV is present. We take the next ignition cable and see that 26 kV is present here too. The measurement gives a value of 26 kV here too. We go to the rear cable and measure 0 kV. This means that the rear cylinder is not involved in the process, as either the ignition coil or the ignition cable is interrupted. We found out very quickly and without a great deal of effort where the fault is.